interuniversitaria che fa parte, secondo noi, almeno lo percepiamo in Expo tutti i giorni, di questo nuovo sviluppo del mondo verso un'educazione multidisciplinare e multisettoriale. Finisco col dire che l'Emilia-Romagna è stata la prima regione che ha, grazie a Bonaccini, fatto dei bandi appositi per favorire la partecipazione delle imprese romagnole a Expo Dubai. È stata una grande idea di Bonaccini, ne abbiamo discusso tanto tempo fa, è un modo di portare questo sistema innovativo e di rappresentazione delle competenze dentro la programmazione delle regioni, facendolo finanziare dai fondi, dai POR, dai fondi europei, dai fondi disponibili, quindi non come un'operazione extra budget, fatemela definire così, ma all'interno della pianificazione e programmazione regionale. Altre regioni hanno seguito questo esempio e quindi devo dire che l'Emilia-Romagna ha stabilito un punto di riferimento anche in come partecipare agli eventi globali che da oggi ci porteranno nel futuro dello sviluppo e della sostenibilità. Qui lo dico sempre, lo ripeto, qui siamo al centro di un'area, questa non è l'Expo di Dubai, è l'Expo di un'area che in un raggio di 5 ore di aereo raggiunge 3 miliardi e 200 milioni di persone di età media di 29 anni, che determineranno i consumi, la domanda di consumo dei prossimi decenni, la domanda formativa, la richiesta di valori chiari, certificati di sostenibilità e di innovazione. Per cui portiamo questo modello italiano dell'Emilia-Romagna dentro un padiglione, spero che voi lo vogliate visitare, che è rappresentativo di questo approccio, di questo modello innovativo, dentro una creatività, come vedete, che abbiamo cercato di dare a tutto il sistema Italia. Non troverete un marchio, un brand commerciale in tutto il padiglione, non c'è niente di espositivo, è tutto dimostrativo di un brand Italia, legato ai valori nuovi della sostenibilità, della crescita, dello sviluppo, eccetera. Quindi vi ringrazio molto, la vostra partecipazione è veramente un tema, è qualcosa di veramente importante che arricchisce molto la nostra presenza qui a Dubai e spero che questo sarà l'inizio di un cammino che potremo fare insieme su tanti fronti diversi. Quindi benvenuti e buon lavoro.
Thank you to the General Commissioner. Everything we have mentioned, including the workshop happening and taking place in the Academia of the Italian Pavilion, has been made possible thanks to the efforts of the region Emilia-Romagna. On this note, I'm glad now to leave the stage to the President of the Emilia-Romagna region, Mr. Stefano Bonaccini.
Grazie per questa splendida accoglienza, grazie commissario Glisenti, grazie a tutti coloro che sono voluti venire qui. Saluto con affetto il Presidente Prodi che ha voluto ancora una volta non fare mancare il proprio sostegno e anche i propri consigli alla nostra Regione. Glisenti faceva gli apprezzamenti a me, lo ringrazio, ma in realtà fu un'idea sua quella di sottoporre qualche anno fa, quando ero ancora Presidente della Conferenza delle Regioni e cominciammo il lavoro che avrebbe portato alla costruzione non solo di questo padiglione, ma come ha ben detto lui, la presenza italiana in questa grande opportunità che è l'Expo di Dubai. E proprio il ragionamento di fare bandi regionali nasceva dall'idea di immaginare che le istituzioni non scegliessero questa vetrina solo per avere una foto in più sui giornali, sui social o per andare su un titolo di telegiornale, ma affinché tutti i sistemi territoriali potessero concorrere con le proprie eccellenze nella realizzazione di una grande opportunità, che è quella di venire in uno dei luoghi dove corre più velocemente che in altri parti del mondo l'innovazione mondiale, potessero venire qui a rappresentarsi. Noi siamo l'unica regione al mondo che porta il nome di una strada, che è la millenaria Via Emilia, che nasce però a Rimini e quindi in Romagna, e dunque il nome contiene entrambe le edizioni, e che di quell'elemento, cioè essere attraversata da un'arteria così importante e strategica, ne ha fatta una cifra dal punto di vista del viaggio, degli arrivi, delle partenze, dell'ospitalità. Una regione che porta il nome di una strada e che sarà il prossimo anno l'unica che ospiterà nel corso dello stesso anno un Gran Premio di Formula 1 che torna in calendario ufficiale. Questa mattina abbiamo salutato chi gestisce la Formula 1, il Circus, Stefano Domenicali, che è un cittadino della mia terra, un motomondiale di Superbike e un MotoGP mondiale. Tutte e tre questi appuntamenti internazionali, ognuno dei quali raccoglie centinaia di milioni di presenze televisive, ma anche un indotto straordinario di arrivi turistici e di appassionati nella nostra terra. Poteva l'unica regione al mondo che porta il nome di una strada non essere anche una, se non la prima Motor Valley per eccellenza nel mondo? E dunque noi siamo venuti qui con le eccellenze della nostra terra, che vedono in particolare nella Food Valley e nella Motor Valley due dei brand che dopo l'Expo di Milano abbiamo addirittura fatti diventare brand di attrattività turistica. Le 2 e le 4 ruote tra le più belle al mondo, prodotti enogastronomici tra i primi al mondo. Questa mattina ci siamo telefonati e qui a lavorare con Massimo Bottura, che negli ultimi 3 anni per ben 2 volte, modenese, emiliano, ha vinto il premio di miglior ristoratore del mondo. E vengo da un importantissimo incontro insieme alla nostra delegazione poche ore fa con la Fondazione Futuro e ci siamo ripromessi in occasione dell'appuntamento che il padiglione dedica, o meglio lascia l'Emilia-Romagna per il 13 gennaio, nel quale presenteremo quello che sarà il Tecnopolo di Bologna. Saluto Mattia Santori, che è qui per la città metropolitana di Bologna come rappresentante istituzionale massimo di quel territorio, che vedrà ospitare a Bologna, in Emilia-Romagna, contemporaneamente il centro meteorologico di riferimento che studierà la climatologia di tutta l'Unione Europea e insieme l'arrivo la prossima primavera di uno dei primi 5 supercomputer al mondo per velocità e potenza di calcolo, che permetterà alla nostra regione di avere da sola addirittura il 21% della potenza di calcolo complessivo europea. Parlo di questo perché il tema dei big data è direttamente collegato e correlato anche a tutto quello che riguarda non solo lo studio della climatologia o della telemedicina e della sanità del futuro, ma anche a tutto il tema che riguarda l'automotive, la meccatronica, i motori del futuro. E allora, per concludere e per lasciare ad Andrea Pontremoli, CEO di Dallara, una delle imprese, uno dei miracoli emiliani, una delle imprese più innovative al mondo e alle cui competenze e personalità abbiamo chiesto, e quindi non ad un politico, ma chi ci può rappresentare nel mondo per quello che nel corso della sua vita ha saputo imparare, studiare, apprendere e poi realizzare rispetto ai temi appunto dell'automotive, della meccanica, della meccatronica, ma con la proiezione nella Motor Valley del futuro, che dovrà essere quella non più dei motori a scoppio, ma che entrerà direttamente nel campo dell'elettrico, dell'idrogeno, dell'ibrido. Ora, perché Motorvehicle University of Emilia-Romagna? E dopo Andrea spiegherà molto meglio di me che cos'è. Perché ci siamo detti che per la Motor Valley dell'oggi, e che vorremmo lo fosse del domani, perché noi quando parliamo di automotive e di Motor Valley Emilia-Romagnola il richiamo va direttamente a marchi straordinari. Io non dico quando giro il mondo, né lo dico qui a Dubai, che vengo da Campogalliano o da Modena. Mi basta dire Ferrari, Maserati, Ducati, Lamborghini, Dallara, Pagani, ed immediatamente tutti capiscono da che parte del mondo noi arriviamo. Ma se la vogliamo proiettare nel futuro e vogliamo che diventi ciò che ha garantito all'Emilia-Romagna non solo quei marchi straordinari, ma oltre 16.000 piccole e medie imprese che danno lavoro a circa 100.000 persone, abbiamo bisogno di scommettere su una cosa, la qualità. E la qualità deriva dall'investimento sulle scuole, sulle università, sui talenti, sui saperi, sulla formazione continua. Motorvehicle University of Emilia-Romagna allora ci ha visto protagonisti nel mettere insieme le 4 università dell'Emilia-Romagna, Parma, Modena e Reggio Emilia, Bologna e Ferrara, insieme a quei 10 marchi straordinari che ci rendono orgogliosi di ospitarli tutti insieme in poche decine di chilometri, una cosa abbastanza unica al mondo. E soprattutto puntare sull'attrattività di talenti. Si dice spesso che dall'Italia i cervelli vanno in fuga all'estero. Ecco, in questo caso noi proviamo a fare l'esatto contrario, portare le competenze e i talenti del futuro a studiare da noi qualcosa che trovano solo nella nostra regione, sperando anche che rimangano lì per darci una mano a costruire la Motor Valley del domani. Grazie e buon lavoro.
Thanks for this message. And as mentioned now today, MUNER is a campus as big as Region, a land of legends, a cutting-edge technology, where the history of the 2 and 4 wheels was written. So you are probably asking yourself why also this setting, and there is this empty space here, because we are going to introduce the MUNER according to different technologies. But before emerging to that, let's relive together the magic of MUNER through these pictures. Thanks.
Can you imagine the cars and the motorcycles of the future? Will they be connected to everything? How will their design change? How will the engine of tomorrow work? Maybe motor vehicles will turn on just with a glimpse, or be as fast as your thoughts. The truth is that imagination requires talent, but above all, skills and training tools that only a great university can offer. This is the reason why MUNER, the Motorvehicle University of Emilia-Romagna, was born. A campus as big as an entire region, where the brands that made the history of the automotive industry and the main universities of Emilia-Romagna merged together to design the 7 automotive engineering careers of the future in electric vehicle engineering, advanced automotive electronic engineering, advanced powertrain, advanced motorcycle engineering, advanced sport car manufacturing, high-performance car design, racing car design. All of them under 3 master's degrees with an innovative learning by doing approach. The most famous automotive companies in the world put their know-how and the most innovative technologies at the service of students to train the engineers of tomorrow directly through their professionals. With MUNER, the most talented students will shift from designing to testing within the most renowned manufacturers with the skills of those are already pursuing the future and bringing it forward. Start here and keep writing the history of 2 and 4 wheels. If you are an engineer with passion for automotive, if you have strong skills and a multidisciplinary curiosity, join MUNER, the University of Motorvehicle that will drive you in the future. Find out more at motorvehicleuniversity.com.
We can give, yes, just and a round of applause. It has been introduced by the President Bonaccini. I pass the floor to Andrea Pontremoli, the President of MUNER.
So, good afternoon. It's a pleasure to be with you today. Also, I feel very proud also to be here, you know, to show what we were able to do in the last 5 years in the Motor Valley. The first thing was incredible to put together all the biggest brands that we have there. So Ferrari, Lamborghini, Maserati, Ducati, Toro Rosso, Alfa Tauri now, us, Formula One, HPE, Pagani, Dallara. And really this was a big challenge for us to put together all these companies. And then I think the biggest challenge was to put together the 4 universities. And, but now we are here. And so I want to recap with you where we are now and what we have accomplished during the last 4 years. And also, as Presidente Bonaccini said, we have to look to the future. It's not only this working for today, but these engineers are the engineers that we want for the future. And this has been designed by the companies for that. So, as I said, you see here all the 4 universities, the companies, and I want to mention also how important it is to have the institution, Regione Emilia-Romagna, with us. Because the territory basically is 3 things. The first thing are the rules, let's call them law. Then we have the knowledge, what you know. And then you have the companies that they put together the knowledge and the rules to create the future. And you understand how it is important, why it's so important to have a correct combination. Because, you know, if I create a law that put the incentives on the pharmaceutical, and then I have the knowledge on the mechanical, and then the companies are working on the wood, is no way to create the future. And so this is very important, that is not an effort only for the companies, it's not an effort only for the universities, it's not an effort only for the institution. All together we have done this. And as I said, I am really proud. And now is happening an interesting thing. We started with 10 founding partners that we mentioned before, and then we had the biggest brand in the world that started to ask us to join us. And we know that innovation means openness. You can be innovative only if you are open. When I was the president of IBM, we have done a study asking 1,000 CEOs of different companies, where do you take the innovative ideas? And you know, only 30%, 30, of the innovative ideas come from the employees. 70% come from outside. And so we have to force the openness if you want to have a future. And this is why we have added now these regular partners that are selected by us, because we have a lot of requests, and so we carefully choose who could be the partner. We have AVL, we have CNH, ST Microelectronics, Pirelli, and Bosch that asked us to join us. And then you see here that we started with 6 professional master degrees. Now we have 7, and next year we will have 8. So we are enlarging also the kind of knowledge that we have. And here is very important that is also the practice that is very important. I think that you will experiment later on some of this, what is the meaning of learning by doing. And this was really a big effort of our companies, because we forced ourselves to have companies designed to be visited. And so you can come to Ferrari, to Lamborghini, to Dallara, to all the others, and you can visit the company, and the students, they come and they use the tools that we are using normally. The wind tunnel, the driving simulator, the bench tests for Formula 1 engines. And you know, this is something that you can only maybe see a picture of these tools. And here are tools that you are using every day. This is very important, I think. Then, this is where we are now. 90% of the graduates are immediately involved in professional activity in the automotive sector. By the way, 100% of the people, they find a job before they finish. And 90% of them, they are in the automotive area. More than 20% are non-Italian, and we want to have more of them, and this is why we are here. because I want to have more students from abroad, because diversity is the name of the game, again, for the innovation. And the other thing is that with Stefano Domenicali, with the Formula One CEO, we have agreed to offer scholarship to increase gender and minorities representation in our program. So these are all the things that we are putting together, and now I'm working also on another project with Formula One again, to put the Formula One flavor, let me say, on the schools, not on the university, but also on the schools. And we want to announce this in the next year, and it's something that is really important because we have to find early enough the people that have the passion for STEM, science, technology, engineering, and math. Because if we wait too much, we lose a lot of passion. So we want to have this. And here is my message to you. A simple message. If you dream to design the future of the motor vehicle, come to us, join us, because we need your capabilities. And this message is for the students. Okay? Thank you for that, and I hope that you will enjoy.
So, as been mentioned, the learning by doing approach, the new skills that also our General Commission mentioned at the core of this pavilion. And so I'm glad to leave the floor to Mr. Leonardo Guglielmetti and Professor Francesco Leali that will lead us to the experience of today. So I will ask to the directing to share the two microphones to our two speakers. Please be on the stage.
And welcome here today. We are a delegation from the 4 universities of the Emilia-Romagna region, students, researchers, and even educators. Sorry, I prefer to use educators instead of professor because it's not an academic role, but it's a job, it's a mission to be part of this system. I asked to the students and the researchers to join us here in the middle since we are preparing the next demonstrator. It's a very short demonstration today, but the entire lecture is more or less 45 minutes for students, and is 3 different virtual vehicles in the middle of the square here. You have the possibility, 10 of you have the possibility to wear a headset. We prepared them and we calibrated them. As you can see, we have a QR code in the middle of the room. So according to that, we have 3 vehicles in the middle of the square. And using the headset, you have the possibility to see the vehicle and to interact with the vehicle. For people without the headset, you have the possibility to see the demonstration on the screen in streaming. So you can see exactly what the guys, what the students are doing here. Then, a few words about the specific case studies we prepared for you today.
Thank you to all. I'm a pleasure to be here. I'm Leonardo Guglielmetti. I'm the coordinator of MUNER University. And so we speak about the competence of the future. We are speak about of the learning by doing. And so we have also speak about the innovation. But innovation also using a new tools that is augmented reality, in which we are going to see 3 different kind of experiences using these tools that is the HoloLens that our guys has already prepared. So the first of all is to join the assembly of a Formula Student car with the engine, the normal combustion engine, and also the assembly of the battery for an hybrid car. The second experience will be to check the flow of the power between the tank, or the fuel tank, or the battery. And the third one will be an experience looking about the sound of the car that is studied into an echoic camera. So I ask to the guy to prepare the setup, and I involved.
Yeah, we need 10 people to
test
the
try and discover this experience.
Please. Commissioner General, President, please.
It's not dangerous.
No. It's like
You can
an
wear the
hologram.
headset over there. Five people. Okay, five.
Prego.
One headset for the president, please. They are calibrating now the headset, so they are looking around in order to find some point of reference in order to have the best position of the vehicle in the middle. And as you can see, the strange movement they are doing is just to set up the system. Just a few words about the Formula students. You know, it's a challenge between universities. It's not a race. A race is part of the challenge. Students have to design and manufacture their own cars or vehicles, motorbikes, and then they have to pass some tests in an international environment. Now they are looking to the QR code in order to find the position. And now the headsets are ready to go.
We are ready.
Okay, so if you want to move to the center of the square, we have the possibility to share other 3-4 headsets, so if you want, just wear it. Yes? So you are in the real environment, so other 2 headsets, please, here, guys.
Lo regoli pure lei con la rosellina dietro. Lei vede già, Presidente? Vede il veicolo lì? Ok. Ok, potete, chi ha già i visori potete parlare verso il centro, guardare verso il centro della stanza. Se qualcuno non vede nulla lo dite che...
May we share the screen, Matteo?
Ok, un attimino che abbiano tutti i visori, poi partiamo. Un certo. Ok, mettetevi anche avanti.
Prego. Io se vuoi cambio le gomme.
Sì, si partite in inglese. Hello everybody, my name is Valerio. Me and my colleague are going to guide you to this through this unique augmented reality experience. As you can see, maybe in a few seconds, also in the screen, we are not crazy, but we are watching a virtual car here in the middle of the room. You can't interact with the car, so if you want, you can only point with your finger to some features. Non vede nulla?
No, dovrebbe vedere.
Sì, stiamo aspettando per far vedere anche gli altri. Okay.
Okay, now you are into the system. It's
Yeah.
also possible to connect in a remote mode in a virtual reality environment. So it's more or less the same, but the entire room is in virtual reality. Now here we are in augmented reality.
Un attimino, aspetta. In realtà dovete solo assistere perché non potete interagire in questa versione, adesso modificheremo noi qualcosa. Sì, e punti il volante, vediamo se si funziona. Esatto. Provi anche a entrare nella macchina e simulare. Sì? No, può entrare tranquillamente. Sì? Ok. We are ready. You all can see in the screen what we are watching now. Okay, let's start in this very short presentation, very short demonstration of this virtual reality. We are going to show you this first car. Is a Formula SAE car. Exists different type of Formula SAE car, electric car and combustion car, and this is the only one car in the world which mount a hybrid power unit. Okay, as you can see in this other representation of the vehicle, these are the components of the hybrid power unit. Here is the internal combustion engine, the electric motor, and here highlighted you can see the fuel tank in yellow. And in this animation, you can see also the fuel flowing to the internal combustion engine that represent the flow of energy passing through the chemical energy of the fuel converted in mechanical energy by the internal combustion engine. Let's now focus on the battery pack highlighted in green. And here you can see also the flow of energy passing through the battery toward the electric motor converter. This component is the inverter that is able to convert the DC current in AC current and deliver to the electric motor. Okay? The electric motor is directly connected to the internal combustion engine. It's a very particular architecture, and the energy is then coupled between the electric motor and the internal combustion engine and converted in kinetic energy of the vehicle passing through the transmission system, highlighted now in blue. At the same time, we can also consider the braking system of a hybrid vehicle, where the energy passing through the transmission is then converted in the reverse direction, passing through the transmission, then to the electric motor, and converted again in DC current in order to be stored again in the battery. Okay? We need to be very quick in order to show you other features of this very important and useful virtual reality. My colleague now is going to show you a simulation of an assembly of another type of vehicle.
Okay, so this is a different car from the previous before. The difference is that this car is fully electric, and I will show you in particular the accumulator battery. Now we can see the core of the battery. We call it a module. It's composed by a battery management system. The cells, there are the cylindrical lithium one that you see in pink, and then cubic material that you can see in blue is called PCC material. It absorbs the heat spread by the cells during the race and allow us to keep the cells at a constant temperature during the whole race. At the end, you can see the chassis of the module that keeps everything in place. In fact, for regulation, we need to withstand a deceleration of 40 G lateral and vertical. Now we will assemble the module. And after that, we will place it in the whole battery. The battery is composed by 6 of these modules to reach the high voltage tension of 600 volt. Now we can see the case, the upper cases, as inside the management system of the battery for safety reasons. It checks the tension of the series of cells and also the temperature, that is very important. The lower cases, as I was saying before, have to withstand a deceleration of 40 G and a penetration energy maximum. Now we will assemble also the case. Now we see the conversion of the energy from DC to AC. Those boxes that you can see on the battery are the inverter that converts the DC power to AC. Placed everything on a shelf. Now we add the motors and the planetary gear. Those motors allow us to give the car 1,000 Newton meters of torque and a maximum speed of 100 kilometers per hour. The whole powertrain is cased in the chassis, that is a carbon fiber monocoque. And now we will mount the aerodynamic devices and the suspension system of the car that you can see assembled here. Now I let the next guy to talk about the anechoic chamber.
Thank you. Yes, I'll be quick and try to be not so technical. I will just talk about the testing that we are doing regarding automotive sector, but any kind of sound sources. I will show you some hints about the acoustic characterization of motor vehicles. And I will start by playing a short video of an iconic laboratory which is in Ferrara at the engineering department of the university. You should see the video popping above the motorcycle just on the top of your head. This is a room we use in Ferrara to characterize sound sources and to measure and record the signal, which is not influenced by the surrounding environment. So placing a lot of microphones all around these vehicles, the two cars and the motorcycles, we can generate some kind of shaded color map coating virtual model, as you can see. The main noise is generated by the electric motor, the electric engine, of course, but mostly by the moving chain. In the last slide, you can hear actually the sound we recorded in the acoustic chamber at the University of Ferrara. You can lower down the volume of your headset using the 2 buttons on your right side. So it's quite annoying. I will stop you for you. And that was it. I will stop now my presentation. And since you actually did not interact with the model, I can borrow my headset to some of you who just want to click some virtual button if you want.
Thank you. Thank you. I would say a first round of a great applause to this test and short demo session. So it's quite an astounding example of how we can use technology for educational reasons, like combining the study with these activities. So now I would like to invite the President Bonaccini, the Commissioner General Glisenti, and the delegation to move to the gallery of the amphitheater to start the journey into the Italian pavilion. But, I mean, our journey in the knowledge of MUNER just continue. And so we are now ready to be and to go more in focus on the challenges of the MUNER project. I'm going to ask Professor Niccolò Cavina just to be and ready to the stage, and I leave the President Bonaccini and the General Commissioner to the gallery of the David to visit the pavilion. Thank you. So, I want to welcome Professor Niccolò Cavina to introduce better and better, with all details, this experience. And I would like to say and go a round of applause to all international students that are watching live and also the present here. Thank you so much.
Lorenzo, thank you everybody for your kind attention. I'm very happy to spend a few more words about what we are doing at MUNER and what maybe to help also better understand what you saw in a augmented reality environment. So one of the values of MUNER is to have students really test and apply their knowledge. And so I'm going to talk a little bit about Formula SAE and Moto Student as projects that we have married and followed in all the universities of the region. So I'm going to be a little bit quick. Most of the things might be known by our students, but what is Formula SAE, what is Moto Student, and what is the MUNER ecosystem, and the reasons for the students, international students, to join. Formula SAE, you've seen one of the vehicles that take part to this competition. It's an international competition in which university students fully design, manufacture, test, and compete with a self-made race car. So everything on the car you saw in the augmented reality environment was designed, built, assembled, tested, and brought to the racetrack by the students, only by themselves, with an ecosystem that is MUNER, if you want, and is the Emilia-Romagna region that supports them and somehow guides them through this path. This kind of competition at the moment allows 3 types of powertrains to be developed, 3 types of vehicles to be developed, 3 categories if you want. One is fully electric, one is with an internal combustion engine, and one is driverless. It can have any kind of powertrain. Most of them are electric. So the students are learning different technologies in terms of energy conversion, but also the digitalization and all the connectivity needed to make a racing vehicle drive by itself. we don't want to kill Formula One, let me say, show, but it could be interesting to see sooner or later some vehicles competing without the driver on board. It's a big thing happening in all the world, and another positive aspect of this educational path is that the students learn to live in an environment that is similar to a real company. So they need to deal with budget, with deadlines, with contacts with institutions, sponsors, and of course, all the steps to develop the vehicle up to the race. Moto Student is something newer, but it has a very similar approach. At the moment, there is just one race all over the world, but we did a first event also in Italy. That race takes place in Spain, every 2 years. We did one first event in Italy, in Imola racing circuit this year, and next year it's going to happen again. So it's getting larger and larger. The idea is the same thing. In this case, the students have to design, build, and race a motorbike, either with an internal combustion engine or with an electric motor. One of the points that make these challenges very interesting is that the team that wins the competition is not the team that has the fastest vehicle on track, maybe not necessarily, because part of the points are awarded for the design phase, for the cost analysis, and for the business plan presentation. So soft skills, hard skills, multidisciplinary approach is the key for the success of a team, not just the time needed to make a racetrack. And why this introduction? Because these type of projects are really very similar to the idea we have in MUNER, and the MUNER ecosystem somehow was started to help students get this type of practical experience on top of very solid and strong theoretical basis. We are lucky, I think. We are in one of the places in which we cannot do other than those things, because we have all the opportunities, and somehow from a university point of view, we are really obliged to offer this kind of service to our students. MUNER is in the center of the slide, but MUNER was born from this type of environment and this ecosystem, and MUNER created a new ecosystem within the ecosystem. So you see the 4 universities on top of the slide. You see the Emilia-Romagna region and the Motor Valley as the founders, let me say, of this type of idea as MUNER. And on the bottom of the slide, you see the logos of some of the racing teams of our region. So you see the University of Modena Reggio Emilia racing team, University of Bologna racing team, University of Parma racing team. You just saw the 3 vehicles from these 3 teams. So you saw the hybrid Formula SAE from University of Modena. You see the electric Formula SAE from University of Parma, and then you just saw the electric motorbike from University of Bologna. So this is the ecosystem that made this possible. And I think it was already mentioned in the previous presentations, but there are several reasons for the students to join this type of program, of educational program, and within this program to participate to those projects such as Formula SAE and Moto Student. The companies today require this type of skills to be developed within the university, and that makes the difference, because the engineers or the graduate students that come out of these projects have already lived an experience that is similar to the one they're going to live in a company, but in a small and, let me say, much more open environment. So they get to the companies with a lot of new ideas, fresh ideas. They want to innovate, but they have also seen the hard part. So they're not just dreaming, but they know exactly how hard it is to translate dreams or ideas into actual vehicles and components. So this is, I would say, the main reason. That there are some others, but these are the skills that are really appreciated by the companies. I'm going to go a little faster. I'm going to present you a case study that is the University of Bologna Motorsport team, which is somehow similar to the teams that are in the other universities. At the moment, our team boasts more than 150 students working on 3 different projects, 2 cars and 1 motorbike. And as I said, the team is organized as a corporate organization. This is actually the structure, the organizational structure. So there is 1 team leader, and I'm very happy to announce that for the first time this year, the team leader is a woman, is a female engineer, and she's managing more than 150 students, a great percentage of which is also made of women. The organization is complex because we have 3 projects, so we have 3 chief technical officers, each of them being the responsible of one of the projects, and then you see all the divisions in the lower part of the slide, from electronics to powertrain, combustion and electric, composites, dynamics, mechanical structures. And some departments are fully transversal, so they offer their service to the entire, to all the projects, such as the marketing and the aerodynamics. I'm going to go quickly through the next slides that show you a little bit what the students really do, what type of topics they develop, what type of research they're doing, and somehow all the complexity they are dealing with. From the mechanical structures point of view, you see that essentially they need to do, first of all, the virtual assembly of the entire vehicle. So a lot of activities are done via software. That's the way in which we want to design things today. Software, and then after, in a software environment, the students have designed and verified all the components, they start the, let me say, the design phase and the production phase together with their supporters and the companies that are part of the project. Composites is another big division. The students do the framework, do the chassis, they develop it with their own hands within the company. So they learn how to do and how to use this innovative technology. Vehicle dynamics, it's both software and real-time tested on a hardware on the vehicle with the telemetry being developed by the students. Aerodynamics, again, software design, analysis of the most efficient wings and elements, and then the production, typically in carbon fiber, and then the testing in a wind tunnel, and then, of course, on the racetrack. The powertrain combustion is one of the divisions in which our team, let me say, spends a lot of energy, because one of the features of this approach is that the engine control unit is fully open software. So the students design all the parts of the software, they test them in a virtual environment, and then they go to the test bench where, with the real engine that has been modified, starting typically from a motorbike or motorcycle type engine, but the intake, the exhaust, and all the main components are modified by the students, and then they are tested on the test bench before installing the entire powertrain on the vehicle. Electric powertrain is the most recent activity we've been doing in the last years. You have seen the assembly of an electric vehicle in the augmented reality demonstration that just preceded this presentation, so I'm not going to spend too many time on this, but from the cell choice to the pack assembly, to the testing, to the test bench of the electric motors, and then finally on board the vehicle. Electronics is a transversal division, so it's both hardware and software. And then going to the motorbike, you see that again we have a chassis that is fully in carbon fiber, monocoque, and then the students design very, very specific components with extremely innovative technologies like laser melting and soldering, which is one of the newest technologies with metallic powders for the swing arm. So some components are really designed, and there is research in that, not only education. Vehicle dynamics, again, for the motorbike, from scratch, from the start. We have a great partner that is Ducati in this case, that helps the student identifying the main elements of the vehicle dynamics before the vehicle is even designed in a three-dimensional way. And then, of course, up to all the process, up to the telemetry on the racetrack to verify that the design was successful, or to go back. Finally, marketing department, extremely important. The budget is significant, and the students have to deal with the companies to raise sponsors, to raise money to fund their projects. This is one of the things that the students do. So they do events, they organize events for the companies, they participate, of course, to the competition, and the marketing department is very, very important, as well as the communication department. Also because part of the race, again, is not only on track, but is also evaluated based on the cost event business plan presentation that the marketing department typically takes care of. Finally, to conclude, these are the prototypes that this year the University of Bologna has put on track. So you can see on the left the internal combustion engine Formula SAE vehicle, in the center the electric Formula SAE vehicle, and on the right the electric motorbike. Some results from the last season, this year actually. Last year we could not race. So this year we did very well in the only competition that was officially the only event in Moto Student, and the University of Bologna achieved the first position, and we did quite good also in Spain with the third position in the Formula SAE combustion. We did also virtual results and virtual races during the COVID pandemic, so we never stopped. The workshop was always open with a lot of testing taking place and all the safety measurements we could put on place. So we did participate to virtual competitions with quite good results. Finally, our main sponsors, Lamborghini Squadre-Corse is the main sponsor for the Formula SAE departments, and Ducati is the main sponsor for the Motor Student department. And of course there are many, many others, so here I'm just listing the main ones. And what's next? Well, next year, all the teams from the Emilia-Romagna region will put on track the vehicles that you can see there. So internal combustion engine and electric-powered Formula SAE vehicles, Motor Student electric, and driverless is the next thing we are working on. So thank you for your attention. Sorry for being a little bit long, but I think I can leave the floor to the next presentation. I don't know if Lorenzo is going to introduce it. Yes? Okay. Okay. Thank you.
So now we are ready to make a new demo session at this time for all people that want to share the experience. So I would like to ask to Andrea, Mattia, Andrea, Francesco, Samuele, Pietro, Valerio, and Matteo to be back on the stage and to leave the visor to all people who want to test the demo session, and also for those who are watching us from home to leave although the distance, the experience through the screen of the Italian pavilion right now, right here at Expo Dubai. We will have this demo session, and then again, I will leave the floor to Matteo, Professor Matteo Giacopini and Davide Secca and Professor Emiliano Mucchi to conclude this official MUNER presentation here at Expo within the Italian pavilion. So, I will ask to those in the public to be at the center. We are almost ready. Okay.
We are just calibrating the visor, the HoloLens, and if you want to try this unique experience, we invite you to come here, and my colleagues give you one of the visor, okay? Just wait, because they are calibrating. When the calibration process is done, they give you one of the HoloLens. Sì, non me l'ho proprio dimenticato.
there's someone else that wants to try the experience, the visor is almost ready. Okay, I think if we are all ready, we can start with the experience. The car that you see here in front of you is the unique hybrid car that competes in the Formula SAI competition. And the chassis is a carbon fiber monocoque, and all the aero package and external components are in carbon fiber. And now we are going to see how a hybrid power unit is built and which are the flow of energy in an hybrid car. So we start with the engine. The engine that you see here is a Ducati 959 Super Quattro. It's a motorcycle engine. And to make an hybrid power unit, we have to modify this engine. And to modify it, we have to remove the vertical head and replace it with an electric motor. To remove the vertical head, we have to remove all the screws that hold the engine head to the crankcase. And once removed, we have to remove the chain tensioner, that is the object that you see here on the left of the engine. And now we are able to unplug and remove the vertical original head. The electric motor is directly connected to the crankshaft through the transmission change of the valve train. So we remove the original upper wheel, and we have to replace the original studs with a shorter one to better fitting on the electric motor case. That is a 3D printed aluminum case designed for our electric motor. Once replaced, we are now able to insert the electric motor and to connect again the modified upper wheel of the chain tensioner of the chain valve. Now we put again the screw that hold the electric motor to the crankcase on the left and on the right side of the electric motor. And we put again the chain tensioner to precharge the chain, and this is because the electric motor is designed to keep as possible the original engine. Now we close the chain with a cover, and the hybrid power unit is built and ready to install on the car. If there's no question, we can skip to the flow of energy of the hybrid car. Starting even from the car, we can see the main components that we have on a hybrid car. The yellow one is the fuel tank, where we store the fuel. And the first flow of energy is the fuel that is being converted inside the internal combustion engine. The green one that you see here in front of you is the high voltage battery that sends the DC current to the motor driver, which converts the DC current in three-phase current for the electric motor. Now the power unit elaborates the true power and send to the transmission box to be delivered to the wheel. Now we are seeing a braking phase of the vehicle, where the energy from the wheels is directly to the transmission box, and to the power unit. Obviously, you can see the flow of energy of the fuel because the engine is switched off. But you can see the flow of the current that from the electric motor is directly to the motor driver that convert the three-phase in DC current to be stored inside the battery accumulator. Thank you. If you have some question, I now let the speech to my colleagues from Bologna.
Okay, hi everybody. I will talk about our motorbike for the motor student competition of the Unibo Motorsport team. And in particular, I will talk about the energy fluxes. So, okay, here we have our prototype, Minerva GN. It is a fully electric prototype, and so here you can see all the components of the powertrain. Here we have our battery pack. With on top, we have all the electronic and safety system with the controller on the right. The controller is connected to the HV wiring and providing current to the motor, which will lead to the movement of the wheel. So here in the battery pack, we have the cell that stores the energy in an electrochemical type, which provides electrical energy to the controller. This controller provides a high voltage current to the motor, and the motor can rotate its rotor, transforming the electrical energy into a mechanical one. So we can see here the controller providing the energy to the current to the motor. Just a sec. Okay, here we can see the current passing through the HV wirings. And then here the movement of the rotor is transformed into the movement of the wheel. This energy fluxes is not unidirectional, but is bidirectional. In fact, we can transform the mechanical energy of the wheel into electrochemical energy. How we can do that? We do that with a regenerative braking. So we can transform the movement of the wheel while it's braking into a movement of the rotor of the motor, which transforms itself into a current generator. This current generator will provide to the controller a high voltage current, which will recharge the battery pack, as we can see here. So I will pass the word to my colleague for the acoustic map. Okay, verso la dash. Okay, thank you for the attention.
Okay, we can now switch to the last part of the presentation. We will talk about acoustics. At the University of Ferrara, we have a big chamber called anechoic chamber. You will see now a brief video of that above the car. Above the car. Okay, so in this chamber, we are capable to isolate the sound produced by the mechanical component measured within the chamber from the exterior. So in a normal environment, when you every time you produce noise, every time you produce any kind of sound, your emitted noise is partially rebounded by the walls. So at the end of the day, you feel the merging of your emitted sound with the part of that is rebounded back by the walls. In the anechoic chamber, all the emitted sound is completely absorbed by the walls, which are covered, as you have seen, are covered by these big wedges made by recycled plastic. And we used the chamber, we brought the vehicles within the chamber and we measured the emitted noise. We can do that for research. We are doing that also for company consultancy. We are doing that also for students to make experience and practice with measurements. And yeah, we brought the vehicle, we measured the emitted noise, and here we can, for example, see how the emitted noise by this vehicle can be somehow displayed. So the red color corresponds to high intensity sound, then blue color corresponds to the lower intensity sound. And here we have, for example, we can hear what is the actually emitted noise by this car, which is, of course, an electric vehicle, so we will expect an high frequency noise. Just listen to that. You can also turn down your volume because sometimes it gets a little bit annoying. So yeah, this was just an example to understand what the possibilities made by this chamber. So this concludes the presentation. Thank you, everybody, for being here.
Thank you so much. Thank you so much, and I would like to say also thanks to all those that are watching us from home that are able, thanks to the technology, to see the direct experience of the augmented reality and the learning by doing approach of the MUNER project here at Expo Dubai within the Italian pavilion. And now it's the turn of Professor Matteo Giacopini and Davide Secca, and I leave to them the floor, please.
So, thank you so much. It's a pleasure to be here. My name is Matteo Giacopini, and together with my colleague Davide Zecca, we are two of the faculty advisors of the Learning by Doing project at MUNER. In the next few minutes, we would like to really briefly, introduce you some additional technical detail about some of the vehicle, you've seen in the augmented reality experience, we have performed so far. In particular, we are going to present some further detail about the hybrid Formula Psi car developed by the University of Modena Reggio Emilia, and some other detail about the full electric car developed by the University of Parma. Here we got some performance characteristic of the hybrid car developed in the University within the laboratory of the engineering department Enzo Ferrari of the University of Modena Reggio Emilia. The car presents a peak power of about 80 kilowatts. a maximum speed of about 150 kilometers per hour, and a 0 to 100 acceleration time lower than 3 seconds. The car is then equipped with a carbon fiber chassis, an advanced suspension system, a full aerodynamic package, and obviously a hybrid power unit, which is the main part presented in the augmented reality experience. As you've seen so far, the power unit is developed starting from a Ducati 959 V-twin engine, in which an engine head is removed and substituted by the electric machine. An important peculiar aspect of the project is the fact that throttle transmission between the electric motor and the crankshaft of the internal combustion engine is achieved by means of the original engine valve train actuator change. The electric motor has been custom designed, developed, and manufactured by the team, by the student, and a quite peculiar aspect is the fact that the case of the electric motor has been realized and built adopting additive manufacturing technique, exactly the same technique used, for example, to have the copy of the David of Michelangelo here at the pavilion. The reason of adopting such an innovative technology is the fact that the design of the case is very complex in a way to perfectly fit the original deck of the engine in a way to obtain a perfect plug-and-go solution. Another innovative characteristic of the power unit is the fact that the engine is installed in the vehicle longitudinally. This is a unique feature of car developed in Modena, Reggio Emilia since 2015. A peculiar characteristic that allowed the team to be awarded with several awards at the different events it took part during years. For example, the Most Innovative Powertrain Award in Hockenheim 2016, and the Best Powertrain Installation Award in Silverstone 2019. The carbon fiber chassis has been designed in a way to reach the best compromise between performance and cost. In fact, instead of use classic mold-based technology, the chassis is completely composed by flat panels, which are definitely easier and cheaper to be laminated and then glued together on the outer border. Other main structural components are manufactured using innovative technologies such as, again, additive manufacturing and carbon fiber layup, and they are all designed using advanced modeling and simulation numerical techniques. Same simulation are used, for example, in order to optimize the aerodynamic package in order to obtain the best performance in terms of ratio between downforce and drag of the overall vehicle. Finally, the battery pack is obviously another important component of a hybrid power unit. It presents an innovative concept since it's a solderless battery pack in which all the electric contacts are obtained using a sort of axial preload on the different cell provided by a dock design cap screw. Moreover, a water cooling strategy is used in order to control the operating temperature of the battery pack, and this is obtained by the design of an ad hoc cooling plate. I ask now Davide to join me on the floor and present the main aspect, and peculiar characteristic of the full electric car developed by the University of Parma.
Hello everybody. At the University of Parma we are at the second generation of electric car. We raced last summer in Hungary and in the Italian race, having the best results of our history, arriving 5th over 20 teams in overall, and having second place in design event and third place in business presentation event. Our car is a direct evolution of the first electric vehicle. We started from carbon fiber chassis that was mounted on the first electric car. It had 2 motors at the back of the vehicle, powering the rear wheels, and a battery placed right behind the driver. The second electric car, the one we just raised, has the same philosophy concept, but was improved in every aspect by working on reliability and most of all performance. And as you can see, we reduced a lot of weight, which was part of our success. I want to talk you through one of the main components of the car, how we built it. So the chassis is a monocoque carbon fiber with a sandwich of honeycomb structure. We start from design of the layup of the carbon fiber, and we do a simulation of bending tests, and then we validate those simulations with the real bending tests on the machine. So we then start to CAD model. We divided the car in multiple areas where we decide whether we want to have lightness or we want to have strength. And then we run a FEM simulation to analyze where are the main stresses around the chassis. When the car is ready, we start to the production. We use carbon fiber molds for our production, and we work the carbon fiber monocoque ourselves in our facilities. And here you can see one of our guys working on the first layer of the layup. Aerodynamically, we work a lot on downforce because we wanted to achieve a higher cornering speed to reduce the lap times. In the graphic on the right, you can see a simulation of lap time with the same car, but with older or new aerodynamic package. In the older one, we have the purple line, and in the newer one, the orange line. You can see that highest speeds are almost the same, but we have shorter braking zones. This means we are having less time spent in braking. And then in the middle of the track, you can see that we have higher velocities in the mid-corners. In the powertrain division, we worked downsizing the motors to 60 kilowatt motors. They are paired with planetary gearboxes, which are really lighter than traditional gearboxes. And this provides us with the same torque we had last year, but with a lighter solution. And then the accumulator, so we worked with new cells, and we self-developed the BMS, the battery management system. All the electronics on it were built by our own design, and this helped us to have a more reliable car and to troubleshoot really faster. Now I want to emphasize the testing, because when you finish your car, you have to test it around the track and to gain confidence, to understand it better. And we wanted to do this the right way, so we shortened the production times to have 2 months just for the testing purposes, and ultimately gave us a success result. Thank you for your attention. I leave you to Professor Emilia-Romagna for the anechoic chamber.
As already been announced, Professor Emilia-Romagna for the silent development. Please, the floor is yours.
So thank you. Sorry. So yes, my name is Emilia-Romagna. I'm a professor at the University of Ferrara, and I'm trying to shortly describe what is the silent development. So what does it mean actually MVH in an anechoic chamber? That actually regard also our demo, augmented reality demo that we have a few minutes ago. So first of all, what is MVH? So NVH stands for noise, vibration, and harshness. So if for sure noise and vibration is something that more or less you know what actually is, regard the sound or regard the perception in terms of vibration. On the contrary, harshness is a quite complicated topic to be explained, but can be considered like a subjective quality impression, so something that regards sound quality. Why it is quite important to make measurement or perform activities in an anechoic chamber. So what is actually an anechoic chamber? It's a special room in which all sound reflection are cancelled. In fact, anechoic means free without echo. In particular, here you see the big anechoic chamber that is present in our city, so at the University of Ferrara, can be actually defined into different layouts, in the semi-anechoic layout or in the full anechoic layout, where also the floor is composed by this kind of wedges. From the exterior to the interior, we can see a concrete shell, quite impressive dimension of more than 10 meter by 10 meter by 10 meter, with a steel frame internally, and again internal panels, and finally coating wedges that have a dimension of more or less 2 meters as 8, so quite huge, made of polyester fiber. In this chamber, above 50 Hertz, the 99.9%, so more or less the entire quantity of sound energy that impact the boundary surface is dissipated into heat, rather than, as in this room, for example, mainly being reflected. So wedges are capable to absorb the sound wave and to provide a great sound isolation from, for example, outside. Why I'm going to present this quite special room? Because MUNER students can enter in this room during the lesson and can also practice themselves, making some experience, in particular by using an approach that is the learning by doing approach. Students can make a real, for example, noise and vibration measurement in the car, as you can see here in the picture, and obtain some spectrograms, so some plot that tell you the main sources of noise and vibration. Here are other details about some real measurement that the students during the lesson, the practical lesson, can carry out. For example, here you can see a torso with 2 microphones in the here, on the right and on the left, just to improve the quality of the measurement and go to be clearly seen and to be actually more give you some impression about what actually a real person can feel in the passenger compartment. And finally here, one of the main plot or main result of what the student at the end of their project can do is some noise emission mapping. So some map where some hotspot, red hotspot are present, and that can identify the main sources of noise and vibration. In particular, in the left, in the top left, you see that the main sources regard the engine. On the contrary, in the bottom right, the motorbike in operational condition, you see that the main sources of noise and vibration come from the chain, for example. And this is some example of a real experience that the student can have in this anechoic chamber. And this was my last picture, so I'm going to conclude, and thank you.
So we are really at the end of the presentation for today. I would invite everyone to give a hand to the team that made this all possible. Thank you. This gratitude goes out to the Emilia-Romagna region, Arter, and of course MUNER, the university. the university that combine the four top universities of Emilia-Romagna region in the sign of the automotive engineering. We are just at the beginning of an incredible journey, and so, ladies and gentlemen, all people that follow us from home, is everyone and every thanks for me and from the Italy Expo team for now. Thank you for being here with us. And again, how I would say, how we say in Italian, viva MUNER. Thank you.